Okay guys, here we go with question 10. As ever, I'd love it if you've tried this question first. Maybe you don't have enough time, maybe there's a reason that you can't. If you can, do so. Okay, feel free to hit pause at any point during this video so you can sort of consider the question and think about your answers. And as ever, let me know if there's anything that I've not made clear. We're dealing with, I would say, I've had classic questions before. I would say at this stage, a classic context, okay? This is one of the things that comes up a lot in our questions about gases, which is the classic sealed syringe. You've got a syringe with blocks at the end, okay, and you can push it down here, okay? First thing, nice and easy question to start off, really common one. State in terms of particles what causes pressure of a gas, okay? Now what causes pressure in the gas is collisions. I think pretty sure this is underlined and absolutely 100% required. Collisions between the particles and the walls of the container. This is such a common question. I would say the where students sort of trip up is that they don't use the word particles. If the question says in terms of particles, yeah, you must refer to particles. I use the suggestion, explain in terms of breakfast why you are hungry. Why are you hungry? Well, because you haven't had any breakfast, okay? You must use the word breakfast in that answer. And here, if they're saying in terms of particles, then you must use the word particles, okay? We're looking for that idea of collisions with the walls of the containers. Sometimes students write about collisions between the particles. That's not what we're interested in here. We're interested in the container. Nice stating question now. We're going to heat the syringe, state the change, if any, to the average speed of the particles. Well, the speed is going to increase. Okay, if we heat it, we're putting more energy in, we're increasing the energy, we're increasing the kinetic energy, but you don't have to do any explaining there. Some students will go off and try to explain the whole thing. It doesn't say explain, it just says state, so that's fine. We're now going to talk about the volume of the gas being kept constant, fine, it's sealed, as it is heated. And now we're going to, again, explain in terms of particles. I hope I use the word particles, yes I have. Okay, why the pressure increases. This has all been building up to this, okay? You notice there's really a nice trail of questions here. The first one is talking about pressure, second one's what happens to the speed, and now we're going to use these two ideas to explain this final one. The particles have a higher kinetic energy and speed, and that means there are more frequent and stronger collisions. Now, this is a really key point. A lot of students will know that there's more collisions, but actually each one of those collisions is stronger. Okay, so we've got more collisions, each of which are stronger, which create a greater force on the surfaces that we're dealing with. Okay, greater force, therefore means a greater pressure. So when you're explaining this one, for the higher temperature, when we're heating, you can talk about more, stronger collisions. If we, for example, talked about changing the volume, some of you will know that if we decrease the volume, that will increase the frequency of collisions, more collisions, and therefore that will allow us to have more collisions and therefore more pressure. We're going to scroll down. Oh, no, we're on the end of the question. That was a nice one there. Okay. I feel like I've missed a bit here. I'll find it later and put it in another video. All right.